Hi everyone. Today we are going to talk about AWS infrastructure. AWS is able to serve thousands of customers and millions of workloads. Ever wondered how we do it? This is how we do it. We have divided the world into something which is called as regions. We have 30 plus regions available there. Every region has 3 or more availability zones. AZs are a collection of one or more discrete data centers. AZs are spread across hundreds of kilometers. So all you have to remember is RAD, regions, availability zones, data centers. Every region will have 5 VPCs. What are VPCs all about? They are a logical construct that allows you to stash all networking components inside it. You can have one VPC for dev, one for stage, one for prod. Or you can have one VPC for one application, one VPC for another application, and a shared VPC for collection of logs. So how does a VPC look like? I'm going to draw it shortly and introduce you to the components of VPC. We are assuming we are inside a region which is called as US East 1. I've drawn a VPC now. We are going to have 2 availability zones. Whatever we draw on the left-hand side of the square box would be drawn same in another box, so as to achieve HA, which is concept of high availability. We are going to host a e-commerce website. All publicly accessible components like EC2 instance, it will be placed in a green box, which is called as public subnet. And all the private components like user login, user credentials, order history will be stored in a database, which will be hosted in a private subnet. I hope you saw we drew 2 identical boxes, AC1, AC2, with public and private subnet in it. Now, we are going to place EC2 instances inside the public subnet. These EC2 instances will have a public IP address and a private IP address. We will place a database now inside the private subnet. Both EC2 instances will be talking to the master database. There is a kind of replication which is happening between the master and standby, which we will see in upcoming sessions. Now, to access this EC2 instances from the internet, we are going to attach IGW Internet Gateway to the VPC. This allows users from internet to access my EC2 instance. And that's how they're able to access my e-commerce store, which is hosted on EC2. You'll see me drawing an arrow, which is going towards EC2. You'll get a response back as well. However, you cannot access the database directly from the internet. Think about it why. Now think about the scenarios where you want to patch the database. How will you do it? Because every device which is connecting to internet must have a public IP address. But the database is in a private subnet. It has a private IP address which I don't want to expose it to people. So how would you patch your database? How would you give updates to it? We are going to introduce to a new component in the VPC, and that is called as NGW, NAT Gateway. We are going to place a NAT Gateway in the public subnet. So you saw there's an entry which would be there, which is allowing us to hop or to route from database to NGW. It goes to IGW and then it goes to the internet. So what are we doing here? Just think about it. Assume the IP address of the database is 10.x.x.x. NGW will attach the public IP address to it, which makes it 50.x.x.x, which means a network address translation happened here. Think about a bad guy out there in the internet. When someone is trying to sniff what is this 50.x.x.x, maximum they can reach out till NGW. They cannot know or they are not able to identify that this particular traffic request, it was initiated from the database sitting in my private subnet in the VPC. So the bad guy can never reach till your database out there. They can maximum reach only till NGW. That's how you kept a database safe in the private subnet using NAT, which is called as Network Address Translation. If you're further interested, I want you to go and read about what is NAT in depth, along with differences between NAT Gateway and NAT Instance. Lastly, I'm going to introduce you to route tables. We have this route public and route private. You'll attach a route tables to the subnets, one for the public, one for the private. There's an entry in public which says towards internet, proceed towards IGW. And in private, there's an entry which is proceed towards internet, first hop on to NGW, enter the public subnet via IGW access internet. There's also an entry for local, which allows the components of public and private components to talk to each other. That's it from my end. Thank you.